Here we've got some equations that are representing different chemical reactions, and we're trying to identify the equation that represents neutralization. So in neutralization we have an acid and an alkali to produce a salt and water. Okay, what we need to remember is that acids have predominantly hydrogen ions, alkalis have predominantly hydroxide ions. The salt will be made up of whatever the other the non-hydrogen or hydroxide ions are in the acid and the alkali. So say you had hydrochloric acid, it would be H plus and Cl minus. And if you had sodium hydroxide, it would be sodium positive and OH minus. So your salt would end up being the sodium chloride. And then your water is, of course, H2O. If we look at these equations to find something similar, we can see water is produced in two of these reactions. So these are our two possible neutralization reactions. It has to be something that produces water. There's also water produced in this one too. So that rules out B and E because they're not producing water. However, we need our reactants to look like an acid and an alkali. So hydrogen and oxygen are not acids or alkalis, they're just non-metal gases. So that's not going to be that one. Then here we've got methane and oxygen. Now neither of them are acids or alkalis, so it can't be that one either. Which then leaves us with D. And although we haven't got any other ions there, there is a hydrogen ion and hydroxide ion, which represents an acid and an alkali, combining to give the water. So D would be the one that best represents a neutralization reaction. All the other ones that produce water are actually combustion reactions because there's something burning in oxygen to give water and carbon dioxide if the carbon is there.